Let's talk about L'Hopital's rule. Now, L'Hopital, I think that's the name of some probably French mathematician. And L'Hopital's rule is a rule that helps us calculate limits. So this is one of those rules where you wish you had learned it in first semester calculus because it would have made your life a lot easier. Now, we can only use L'Hopital's rule for certain types of limits. We can't use it whenever we want. So what are the two types of indeterminate forms where we could use L'Hopital's rule? So the first thing I want to do is I want to tell you that we're going to be looking at the limit as x goes to a of f of x divided by g of x. And you can see that we sort of have a fraction involving two functions. And the indeterminate forms that we're referring to result from what happens when you plug a in for x. So what are these two indeterminate forms? Well, the first indeterminate form is if you happen to get a 0 over a 0. When you have a 0 over 0, you could use L'Hopital's rule. The second situation where you can use L'Hopital's rule is when you have infinity divided by infinity. And we don't really care about the sign, so it could be plus or minus infinity over infinity. But these are the two situations where you're allowed to use L'Hopital's rule. And you check this just by plugging a in for x. Okay, so let me tell you about L'Hopital's rule, the theorem. So suppose that your two functions f and g are differentiable, meaning they have derivatives, and they need to be defined on an open interval I that contains this point A. And this point A is where we're trying to calculate the limit. Now remember, it doesn't have to be defined at A, but it has to be defined on an interval containing A. Okay? And I want you to suppose that we have one of our two conditions. So let's just write out explicitly what we mean. We mean the limit as x goes to a of f of x is equal to 0, and the limit as x goes to a of g of x is equal to 0. That's one set. Or the other case that we have is that the limit as x goes to a of f of x is equal to plus or minus infinity, and the limit as x goes to a of g of x is also equal to plus or minus infinity. So if we have either the first set of conditions being satisfied or we have the second set of conditions being satisfied, then we can use L'Hopital's rule. So what's the conclusion of L'Hopital's rule? Well, the conclusion of L'Hopital's rule is that this limit you're trying to calculate, the limit as x goes to a of f of x divided by g of x, this limit is going to be the same as the limit as x goes to a of f prime of x divided by f prime of g. So what L'Hopital's rule does is it relates the limit of functions and it relates them to the limit of their derivatives. Now, I want to make a quick comment here, note, okay, do not use the quotient rule. Okay, we are comparing the rate of change of f with the rate of change of g. We are not trying to find the rate of change of the quotient. That's something different. We're comparing the relative rates of change of the numerator and the denominator. Why don't we take a look at a couple of examples? Let's look at example 1. Example 1 has a typo, so let me cross this out. Let me fix it. This is supposed to be the limit as x approaches 1 of natural log of x divided by x minus 1. Okay. And the first thing that I want you to notice is if I substitute in a 1 into natural log, I'm going to get 0. Natural log of 1 is equal to 0. If I substitute a 1 into the denominator, I'm going to get 1 minus 1. That's also equal to 0. So you can see we have our indeterminate form of 0 over 0. So that means we can apply L'Hopital's rule. So I'm going to put an equal sign. And whenever I apply L'Hopital's rule, I'm going to put an LH over the equal sign to tell people that I'm using L'Hopital's rule. Well, the limit as x goes to 1, I have to take the derivative of the numerator. The derivative of natural log of x is 1 over x. I have to take the derivative of the denominator. The derivative of x is just 1, and the derivative of negative 1 is 0. So I hope you could see that my limit became a lot easier. Now I can just plug in a 1 for my x, and I get that my final answer is just going to be 1. Okay, so that was a hopefully simple first example of L'Hopital's rule. Let's take a look at another example. Just like in the previous one, I made a typo, so let me rehabilitate this. This should be the limit as x goes to infinity of x squared divided by e to the x. So this time when I plug in an infinity for x, I'm going to get infinity squared. Infinity squared is just infinity, so it's an infinity. Infinity into the denominator, I'm going to get e to the infinity, and e to the infinity is just infinity as well. So we could see that I have infinity over infinity. So I could still use L'Hopital's rule. So I'm going to put an equal sign. I'm going to apply L'Hopital's rule by indicate that by putting an LH on top. I'm going to take the limit as x goes to infinity. I'm going to take the derivative of the numerator. The derivative of the numerator is 2x. And when I take the derivative of the denominator, I'm going to get e to the x because e to the x is its own derivative. Okay. So this time when I try to plug in infinity into the numerator, I get 2 times infinity, so that's still infinity. And when I plug it into the denominator, I get e to the infinity, which is also still infinity. So I still get infinity over infinity, which means I can use L'Hopital's rule again. So I'm going to put another equal sign. I'm going to apply L'Hopital's rule again. I get the limit as x goes to infinity. The derivative of 2x is just 2. The derivative of e to the x is just e to the x. And this time when I take a look at this particular limit, when the numerator is now a fixed constant. So this numerator is just 2, which is just a constant. The denominator is exploding to infinity. It gets really big. Gets really big, right? So the bottom is exploding off to infinity while the top remains constant. That is an infinite limit. That means that this guy is going to go to 0. And that's going to be our answer. Okay. So I hope you enjoyed this video on the basics of L'Hopital's rule. We will look at other indeterminate forms besides the basic ones in a subsequent video. Take care, everyone.